Hey there, chemistry student. Welcome back to the Unit 1 video series. Today's lesson will be 1.4. 1.4 says this: I can draw density differences in substances with a particle picture. If we reference our can-do descriptor list, 1.4 is sandwiched in between 1.3b and 1.5. And as always, remember to kind of rate yourself as to your understanding using this list. All right, so let's turn back to the notepad and let's start talking about what density is. So the definition that I really think of when I think of density is the amount of stuff or mass there is in an object. We know that there are different types of objects, and something I can show you that you can really relate to is this. So here we see two pictures of balls, okay? So one's made of steel and one's made of rubber. And what if I told you that all the balls on the right equate to the mass of a single steel ball on the left? Well, you would tell yourself that the mass of a steel ball, even though it's the same size of these rubber balls on the right, is much greater than a single rubber ball. This is because there's a difference in densities between the two objects. So just because they have the same size doesn't necessarily mean that they weigh the same amount. This idea now circles back to our original definition. Which item would have more stuff in it? Well, we definitely know that we'll have more stuff in the metal ball versus the rubber ball. Okay, so now we can scroll back up, and what we're going to do is kind of think of density in a particle sense, right? So here, drawn in front of you, there are two boxes, okay? And something we can mention is that the volumes, again, are equal. We can visually tell they're the same size. And we'll even associate a number to it. We'll say that this is 1 centimeter cubed, and that the volume of this is 1 centimeter cubed, to really kind of remember that idea so far. So now we can turn our attention to the contents of these equal volume boxes. As we see, they're filled with particles, okay? Particles are the stuff or the mass that things are filled with. We know that, again, the volumes are equal, but because the one on the right over here has more particles, its density is going to be greater, okay? So let's go ahead and we could write that in for ourselves also. So this one has the greater density. This one has the lesser density. And it's simply because per unit volume, the box on the left has less stuff in it. The more particles you draw in the same amount of space means that the density of your drawing is getting larger and larger and larger. If we now turn to the web browser, we can read a more formal definition of density. So density is a measure of how much matter occupies a given amount of space. It is quantified with the ratio of mass per unit volume, and we'll be learning about this equation in a future video, okay? It is useful for all states of matter. At this point in time, it'd be good to pause the video to reread descriptor 1.4 on your own and to gauge your own understanding of what we've just talked about. If you feel like your understanding is very good, there's an additional piece of information I would like to add at this time. So we'll now head back to the notepad, and I want to draw out a relationship to kind of conclude this video. So density is a trend, and there's a spectrum of different densities and densities actually increase between the states of matter. So this side represents low, this side represents high densities, and we will write in the densities that occur. So gases will always have your lowest density. Your moderate densities will be with liquids, generally speaking. And your highest densities will always be with solids. So we kind of ask ourselves, why is this? Well, if we return to the web browser and we pull up another photo, what we can tell is that as we look at gases, liquids, and solid, the spacing of the particles gets smaller, okay? So the tighter the spacing, the more particles you can fit in, and guess what happens? Your densities will keep going higher. So as we kind of look at these numbers here, I start with decimals in this spot. Notice that I get larger whole numbers, and then here at the end I get my largest numbers. So again, between gases, liquids, and solids, the density will increase from top to bottom according to this diagram we can kind of look at here. That will conclude our video today. Thanks for sticking in here. Please don't hesitate to go to chemistry tutoring or to contact your teacher for extra help. Hopefully this served as a basis of understanding where we can kind of expand on future videos. All right, everyone, have a great day. Thanks for listening.